Hey guys, Derek Check here with Team Align, and today I wanted to go through a few items on the Align DFC rotor head to pay attention to when you're either first building your kit or after you've crashed and you're rebuilding your rotor head. So the first item I want to go through here actually is the link rod here that connects the DFC arm to the plastic ball link. I've seen two things here. I've seen guys who don't have this rod bottomed out all the way into the DFC arm, and I've also seen guys who don't have the plastic ball link threaded very far onto the rod. And the issue with this is the DFC rotor head imparts a lot of force down onto this link and rod assembly. So it's very important that the rod and the link down here are fully supported as much as possible. And the plastic ball link here actually gains some of its strength by being threaded into this rod as the rod fills in the center of the link and adds some strength to it. So if you have this far out onto the rod, the link isn't very well supported, and that's where you could see issues with having an in-flight failure or that sort of thing. So it's really important to make sure that you have this plastic link threaded as far onto the rod as possible, and that you have the rod threaded in the DFC arm fully. I usually say you want to be around one thread below the hex portion of the rod here is a good kind of ideal position. I've run as much as 3 threads or so showing, and I've gotten away with it, but I wouldn't run anything more than that. I would try to keep it as threaded on here as far as you possibly can. So that's the first item I want to go through. The next one actually pertains to the rod as well as the bolt here that connects the DFC arm to the standoff coming off of the main blade grip. And I have both of these components right here as spares just so you can see. These two parts are made out of stainless steel. And the issue here that I've seen is stainless steel is an inactive metal. And what that means is it doesn't have the ions on the surface of the metal like something like steel or brass or zinc might have. And Loctite, or thread locker in general, actually relies on the presence of those in addition to the absence of air in order for the thread locker to fully cure. So if you just straight up apply Loctite or thread locker onto the bolt here and thread it into the arm, I've seen where sometimes you don't get full cure strength out of the thread locker. It doesn't seem to quite cure all the way. It seems to loosen up sometimes. So what I've actually started doing is using a product that Loctite makes called their primer, number 7649. And what this stuff does is it's actually mostly acetone. So when you spray it onto the threads of the part, it will actually clean off any of the grease and oils for you. But it also has zinc inside of it. And the zinc actually will put the ions onto the surface of the threads that you need for the Loctite to cure much faster and to actually strengthen the bond of the Loctite into the threads. So I've started doing this on both of these threads, particularly where the link here threads in the DFC arm, so I do that side, and then this bolt right here. And since doing that, I've always gotten a pretty good bond with the Loctite, and I haven't really had any issues with the bolts loosening up or the link here loosening up. So that's something I would recommend doing on these components. It's pretty easy. You just spray the primer on and wait about 5 minutes or so to let it kind of dry, and then you can go ahead and put your thread locker on it and just thread it right in like you normally would and tighten it up. The last thing I want to go over is actually on the Nitro model, so I'm going to swap over to my Nitro and I'll be right back. Okay, so I have my 700 Nitro model here, and I just wanted to go through one quick thing on this that I've seen, particularly on the older limited edition or the original 700 Nitro models that have been converted over to the DFC rotor head. And sometimes through tolerance stack-ups and that sort of thing, it seems like the Swashplate can wind up sitting a little bit lower than what we'd like at 0 degrees pitch. And what happens is it forces you to thread these links a little bit further out on the rod than we would ideally like to see them be at. So what I've done here, and I'm going to show you the two links just as a comparison, is I've swapped from the original plastic link, as you can see on the left there, over to the DFC style with the collar. And what this allows me to do is the collared version will actually sit on top of the A-arm instead of being recessed into it like the original plastic link. So this will boost the link up ever so slightly, and that is actually enough to allow you to raise the swash plate up, and that will let you thread this plastic link into the rod a couple more turns and get it to that ideal position. So that is a little trick, so if you're having that issue, you can go ahead and swap those links out. You'll also have to swap the bolt that threads into here with a slightly longer one. I believe the original one's an M3 by 12, and I think I went to an M3 by 14 just to make sure that I had the bolt threaded fully into this link, because again, like I said earlier in the video, the links rely on the ball links rely on the rods being threaded in fully to kind of give them some strength. So since this is sitting on top of the A-arm now and is no longer recessed into it, you want to make sure you have a little bit longer bolt so that it reaches further into the link and you've got the threaded rod of the bolt all the way into the link here. So that's my last tip for you guys for this video. I hope you guys find this stuff useful, and as always, if you have any questions, you can email me at dchekis1@gmail.com. Thanks for watching.